Hi guys, this is Mr. Richard. So in this video, we are going to work with November paper 2, grade 11. Yes, so this video is specifically for those who are doing grade 11. It was written in Eastern Cape, yes, on November 2020. So specifically today, we are going to work with question 1, which involves analytical geometry. So if you are new to this channel, don't forget to subscribe and click the notification bell so that you get notified whenever I drop a new video. So hope you learn a lot. So first thing first, guys, when you're answering questions in analytical geometry, you first have to analyze. It's good to analyze. Let's go and read the statement first. We are going to read the statement first. In the diagram below, straight line PS is defined by 3y plus 2x, which is equals to 6, and cuts the x-axis at Q, which is 3 and 0, and MQR, it's a straight line, which means PR at 10 and 4, and N, it's 6 and negative 2. It's a point on PS, and Rn is drawn such that PQR is equals to theta. Okay, then right, we are required to calculate. Let's start with 1.1. That is how many marks? 2 marks. Yes, we are required to determine the gradient of PS. What do we know by what do we know by PS there? We were told that PS is defined by this equation, 3y plus 2x is equals to 6. So we will use that equation to find the gradient. Let's get started. Yes, we are on question 1. 1.1. Remember they said that we must determine the gradient of PS. So what is the equation of PS there? It's 3y, not 3x. 3y plus 2x is equals to 6. Right. So we need to make y the subject of the formula. So this is what we are going to do. 3y is equals to transpose 6 to the right hand side. So it's going to be 6 minus negative 2x. We will then divide both sides by 3. Divide both by 3, divide by 3. This and this cancel. Remember, the aim is to make y the subject. How many times does 6 goes into, how many times does 3 goes into 6? It goes twice. So this is 2 all over, this will be 2 all over 3x. Then let's write it in standard form. It will be negative 2 all over 3x plus 2. So this is in a linear form. So we can recall the linear equation. It's y is equal to mx plus c, where m is a gradient. So in this case, the gradient of PS will be negative 2. The gradient of PS will be negative 2 all over 3. Yes, that's how you can calculate the first question, which is in which you were required to determine the gradient of PS, right? Then we are on 1.2. At 1.2, we are required to calculate the inclination of MR. Let's take a look. Let's take a look at MR. Oh, MR, right? So in other words, they're looking for this angle here, not theta. They're looking for this angle that is here, right? So we first have to find the gradient of MR. Then after that, we can find the angle of inclination. We know that the angle of inclination is denoted as m is equals to tan. In this case, it will be tan. Let's say we can say RQX. Yes, we can say RQX, or we can say tan Q. Yes. In this case, we are looking for tan Q here, right? So let's get started. Let's work on this part. Okay. So we are on 1.2. We are required to, let's first find the gradient of MR. The gradient of MR. What's supposed to MR here? Missed there. Okay. What did I do there? MR. The gradient of MR. Which will be, it will be, let's take those coordinates. It will be 4. It will be, remember we have, let's say this is x1 and y1, x2 and y2. Y2 will be 4, our y1 will be 0. Then we are going to have 10 subtracted by 3. So what is 4 minus 0? 4 minus 0 will be 4. And what is 10 minus 3? 10 minus 3, that will be 4 over 7. Right? Then now let's find the angle of inclination. The angle of inclination will be the gradient of Mr., which is R tan, remember that we are looking for, let's say, tan RQ. Okay, this is angle Q there. Let's say angle, yeah, let's say tan QRX, it's fine. Or you can just say tan Q, it's fine. Then you have your gradient there. Your gradient there, it's 4 over 7. All right, tan RQX. Okay, then RQX is equals to, then let's use our calculator to calculate. Yes, let's use our KGFX. We will say second function, shift, second function there. Okay, then let's put the gradient 4 all over 7, right? So let's punch the calculator there. That will be 29,74 degrees. Yes, we have found the inclination of MR. In other words, the inclination of MR is what? It's 29,74 degrees. So this is the inclination of MR. We are done with 1.2. Then let's visit 1.3. Yes, we are looking for the value of theta. You're right. Theta, the value of theta there, it's in PS, right? It's in PS. And we already know the gradient, right? Let's work it out. Let's work it out. Yes, we are on 1.3 now. Okay. At 1.3. They want theta there. Then we can say PQ, because it's on BQ. We can say PQX, tan PQX. But we know the gradient there of PS, right? We know the gradient of PS will be tan. Okay, let's say PQ, angle PQX there. All right, then what is our gradient? From 1.1, we were told that it's negative 2 all over 3 tan, let's say P QX. Then second function again, guys, shift, second function, negative 2. Remember, when we have a negative gradient, we will add by a 180 here. Don't forget that. Those are the rules of inclination. If you forget the rules, it will be tedious when answering such questions. So we are having what there? We are having negative 33,69. Then we are going to add this. Let's say we are going to say angle PQX is equals to, let's add this by 180. So that we leave a positive angle. Then we add this by, yes. So that will be 146,31. 146,31. So to find theta is going to be theta. Remember that theta, it's formed here. So we are also going to use this, since this is theta, we are also going to use this angle here that we have calculated. So to get theta, so we'll subtract the angle that we've calculated, PQX. All right, let's see how are we going to do it. We are going to say 146,31 subtracted by 29,74 degrees. Okay, so what is this? Let's punch our calculator there. Okay. Okay. Minus 29,7474. Okay. All right. That is 116,57. So 116,57 comma 57 degrees. So that would be theta. That's how you can calculate theta. Okay. Then we go to 1.4. At 1.4, we are required to prove that Rn it's perpendicular. I mean, this is a sign symbol for perpendicular. It's perpendicular to PS. So in other words, we have to calculate the gradient of Rn. Note that we know the gradient of PS. The gradient of PS, we already know it, right? So let's work it out. Let's work it out. Then this is 1.4. So let's calculate the gradient of Rn there. All right. We have the coordinates there of Rn. The coordinates are there, it's 10. Let's write it here. Coordinate R, it's 10 and 4. And coordinate N, it's 6 and negative 2. So let's put this x1, x2. Let's calculate the gradient quick as possible. So what is our y2 there? Our y2, it's negative 2. What is our y1? It's 10. So our x2, it's 6. But our x, oh, I made a mistake here. It's supposed to be negative 2 minus 4. Okay, sorry for that. As for x2, that would be 6. x1, that would be 10. So what is negative 2 minus 4? That will be negative 6. And what is 6 minus 10? That will be 4. Then what is 6 divided by 4 there? Right. What is 6 divided by 4 there? Oh, 6 minus 10. That would be negative 4. So negative and negative is positive. So what is 6 divided by 4? When we divide both sides, everything here by a numerator by 2, we are going to have 3. By 2 here, we are going to have 2. So this is the gradient of Rn. So to prove, we are going to say, remember that the gradient of PS, we were given as negative 2 and 3. So we are going to say negative 2 and 3, negative 2 divided by 3 times 3 all over 2. This and this, they cancel. And this and this, they cancel. So we will be left with negative 1. Therefore, we could say Rn, it's perpendicular to PS, right? So that's how you can calculate 1.4. Let's go to 1.5 now. Yes, at 1.5, we are required to calculate the area of triangle RQN. Yes, triangle RQN. We can see that QN is a base, right? And RN, it's a height. Yes, it's a height. So in other words, we need to calculate their distances so that we are able to calculate the area of triangle QRN or RQN. So remember, the area of a triangle, it's half base times height, meaning that our base will be QN and our height will be RN. Let's work it out. Let's work it out. Okay, let's work it. We have R as what? As 10 and 4. And N as 6 and negative 2. So let's calculate this. Rn. Okay. Okay, let's use the formula. You still remember that the distance formula, you can also remember the distance formula. It could be d squared is equals to x2 minus x1 squared plus y2 minus y1 squared. Some can use the one with the root. It's fine. It's still the same thing. So let's start. What is our x1? Our x2. Our x2 is 6, so it's going to be 6. What is our x1 there? Our x1 is 10 squared. What is our y2 there? Remember our y2, it will be negative 2. What is our y1? That will be 4 squared. Remember here it's squared again. So what is 6 minus 10? That will be minus 4 squared. So what is 2 minus 4? That will be minus 6. Okay, so what is 4 squared? 4 squared, that will be 16. So what is 6 squared? It's 36. Okay, so we have Rn squared, don't forget, Rn squared, don't forget, then Rn squared. So what is 16 plus 36 there? That is 52. So we have 52. So root n, root of, when you root both sides here, so this will be Rn, which is root for 52. So we are going to take the one that is positive, because we are working with a positive distance. We don't have a negative distance, right? Then now let's calculate the values. The distance of Qn. Qn there, Q are given as 3 and 0. Okay, Q is given as 3 and 0. We already know n is given as 6 and negative 2. So this is our x1 and this is our x2. So we are going to use the similar procedure, Qn squared. What is our x2? Our x2, that will be 6, x1, that will be 3. What is our y2? Our y2, that will be negative 2, y1, that will be 0. So 6 minus 3, that will be 3 squared. Then negative 2 minus 0, that will be negative 2 squared. What is 3 squared? That is 9. What is 2 squared? That will be 4. Therefore, 9 plus 4. Okay, that is okay. 9 plus 4. Okay. All right, that is 13. Yeah, mental maths. That is 13. So meaning that Qn squared, square root both sides, square root both side. Qn, it's root 13. So what will be the area? The area will be area half. Our base is Qn, don't forget. So it's going to be root 13 times root 52, which is our height. Then let's use our calculator there. We know this is half. Okay, half times root 52 times, times root 13. Yeah. Okay, what is that? That's 13. Yes, that's 13. So meaning that the area will be 13 units. 13 units squared. Yes, it's squared, right? 13 units squared, it's an area. Then lastly, our last question will be at 1.6. Calculate the y-intercept of Mr. MR, right? How do we get MR? We already know the distance. This is what we know. We already know the distance. We already know, the gradient. Remember that the gradient we have calculated at 1.6. The gradient of MR was given as 4 over 7. So in other words, if you put this in a straight line, it will be 4 over 7 x plus c. So we can use q as the coordinate there since it's in MR. So we can use q to find c so that we're able to calculate the y-intercept. So q, it's 3 and 0 there, because this is x1 and this is y1. Let's place our y there, which is 0. Let's place our x, which is 3, so plus c. So 4 times 3, that will be 12. So it's going to be 12 plus 7. It's going to 12 all over 7. Okay, so let's take 12 over 7 to the other side. It becomes negative 12 all over 7, which is equals to c. You may recall that when you're using an equation of a straight line, which is y is equals to mx plus c, this is the y-intercept. So in other words, our y-intercept will be this one. So in other words, y is equals to, our y-intercept is going to be negative 12 divided by 7. Hope you find this video useful, And don't forget to subscribe. We need more subscribers so that we can grow the channel and we grow and we improve our content. We love you.